All right. I want to welcome Dana up here. I want to set the tone a little bit. So it's been a little over a year now. I had the opportunity. I met Dana last year at DevOps Days through networking and opportunity. She was giving a talk last year, and we had a general idea last year, which was, hey, you know, SPS systems, we're moving towards microservices. Things are getting more complex. How the heck do we make sense out of all this? We have some ideas, and we have the means to try to do something really interesting here. And so I think we grabbed coffee, and I tried to convince Dana that this was a really cool idea, and Dana looked at me and said, I don't understand what you're saying, and then I realized I didn't either. But somehow I think that intrigued Dana in some way, shape, or form. And I'm really excited that Dana has put the energy into this, because I think we've learned a ton together. We've learned fast, and we've had some great ideas, and you get into these spaces where you have really good aspirations about using new technology, and then you realize that you have to deploy something serverless. What does that even mean? How do you do that anywhere? And so we've learned a lot together. There's been a lot of ups and downs, but it's been awesome, and she's really battled through some really interesting things, and I'm super excited she took the time to put this together and share some of her learnings and where we're going. So it's been a fun ride, and I'm excited to hear more. Welcome, Dana.
I have this clicker. Hello. So yeah, I didn't put my title here. I'm a performance engineer at SPS Commerce. So what that means is I'm supposed to look at assess the health of our services. That's what I was hired on to do. And SPS is pretty huge. There's a lot of services. So I guess I have a few questions before I start for you guys. I'm curious, like, what brought you here in terms of your experience level? So, like, if you've worked with, do you guys know what serverless is in general? Just generally speaking, raise your hand. Okay, and then have you worked with serverless? Keep your hand up. Okay, very cool. Okay, and one random question: have you watched what is it called? Now I'm forgetting. Wonder Woman. Okay, very good, very good. Okay, so now I want you, for those of you that haven't watched Wonder Woman, you really should get out there and see it. For all of you now, I want you to imagine for a moment that you are, I think I pressed this button, you are the leader of 10,000 Amazon warriors, okay? I didn't know that my CTO was going to be here when I put these slides together. And I thought for a moment, like, oh my gosh, I have to go to the bathroom and quickly change the slide. But luckily, he's a feminist, so that's all good. Okay, so you're imagining yourself as this leader of this commander, and you have 10,000 warriors out there. So this is our services in AWS. This is a bit what it looks like. It's you know, I don't. Do you get this joke here? They're Amazon warriors. Oh, okay. I was proud of that today. And you want to understand the health of these all at once, okay? So how do you monitor the health of this battle going on? There's a lot going on out there. Well, you might enlist help from someone else, from another team. You might pay a service to help with monitoring services that maybe specializes in monitoring. Okay, so we're going to call this, maybe you want to reach out to the Oracle, the all-knowing Oracle, who has all the information about your service health. So really, actually, it's not our database. We're paying someone else to collect all of the information about our services, and then they're displaying this information for us in real time. But we wanted to do some more interesting analyses on this. Instead of just looking at them in real time, we wanted maybe a historical trends. We wanted to do load tests and say, hey, during this load test, we noticed that this is different from this last load test, and this is the one thing that we changed. So then, you know, we can figure out some root cause analysis. Okay, so unfortunately, because this isn't our database, we can't speak to it directly. I would love to just say, give me all of your data. But we have to go through Hermes, the messenger god, which is also their API. Okay, so, and then I would love, in an ideal world, you know, so Hermes goes, asks the Oracle for data, you know, and brings it back to us. There we go, Hermes. That's going to get old, forewarning. So in an ideal state, I could just ask Hermes, like, hey, Hermes, will you please tell the Oracle that we want all of our data? And then Hermes would go get the data for us. Here's your data. Okay, but that's not the way it is. This is reality here. I'm going to explain to you the process in which I can get the data from this other service. And it's our data. We're giving it to them, and then I'm asking for it back. Okay? But all of our services are collectively. So it would be way too hard to try to reconfigure all of our services to start sending me directly the data. So this is what I have to do. I have to, I have to ask Hermes, hey, Hermes, will you give me the device groups for all of our data, please? And he goes, I told you you would get sick of this. And he's like, hey, here's your device groups. Okay, so that gives me this like top order, this top list. It's a list. It's more than 3. It's closer to 300 plus for just production. There's like 300 plus device groups, okay, which are like clusters and of devices. Okay, so then I'm like, I take one device group and I say, hey, Hermes, for this device group, will you please fetch me my devices? Okay, so then he goes and he comes back and he's like, hey, here are your devices for this one device group. Okay, so that gives me this next level of this tree. As you can see, I'm building a tree here. So then I grab one of these devices, and what do you think I do? I say, hey, Hermes, for this device, could you please fetch me the data groups? I'm still not getting the data. So he goes, and he comes back, and he says, here are some data groups that are associated with this device. Okay, so now I have this like third level of the tree. I have data groups. Now, this is the interesting part. Now, for a given device and data group, I can ask the API to give me the data that I want. Okay? So then I ask Hermes. He goes to the Oracle. He comes back. And he says, okay, here's the data that you were asked for. So finally, this is the data. But now looking at this tree, you see that along these questions, I have to keep these states. I have to keep track of all the rest of these things and ask. So it becomes sort of like multiple for loops, or if that's how you wanted to implement it. So I guess this was when I first joined the SPS Commerce. I was presented with this API, and I thought, okay, how could I collect all of the data from this API? How should I write the code? And I'm comfortable with Python. So my first iteration, I just used Python multiprocessing, and I put it on an EC2 instance. Is that laughable? like what a funny way to solve that problem. Okay. So this is easy for me to implement, but we picked a really big EC2 instance, and so the problem with that is if I wanted it to go faster, if I wanted the process to go faster, I could pay for a bigger EC2 instance, but if I wanted to scale it more, I would have had to change my code and configure it to handle horizontal scaling, which I just, I wasn't sure. I felt like managing the multiprocessing would be difficult for me. I wasn't sure how to go about that. And in an EC2, like if I have my code running out in an EC2 instance, there's ongoing maintenance and management of that. And SPS Commerce, like a lot of my colleagues have been really interested in starting working with serverless. So I thought, okay, well, maybe serverless, maybe not. What is this fancy thing called a spot instance? So raise your hand if you know what a spot instance is. Okay. So it's an EC2 instance, but you pay for it on demand. So you bid on it essentially. So you make a price that you're willing to pay, and if the market says that that's okay, then you can pay for that. Otherwise, it just won't give it to you. And at any point, it can say, okay, well the market doesn't. This is more expensive than you're willing to pay for, so it can shut it down. So it's cheaper, which is awesome, but it's less reliable because it can shut down at any moment, and then I either have to write code to like manage like where I was at in my process, or I could just start over, but that's a lot of like redoing stuff. Because if I just like, when it kills, like, okay, just start it back. And that's honestly what I was doing. I was just like, if it died, I'd be like, okay, start the, like, you know, pay for another spot instance. I didn't have it automation around this. I was just like manually starting another spot instance, and it was really gross to maintain. So then I thought, maybe I'll try serverless. Because I would really like an ongoing process that's collecting all of the data so that I can just focus on analysis. I'm not a data engineer. I mean, now I kind of am. But I came into this feeling like, okay, I just want to do the analysis. So let's figure out some sort of process that it can just be running in the background and I don't have to maintain it anymore. Okay, this required a paradigm shift for me. And I'll just kind of walk you through this sort of like, this is the way that I view how serverless is in the computing world. People used to always have family cars. And that was like running your own server at home. Then cloud computing came about, or also the ability to lease a car came about. Okay? So that's like that is similar to using the cloud because you're always getting the latest. Maybe you rent a EC2 instance for 2 years or for a year, and you're getting like good quality stuff that's managed in a data center for you. Leasing a car, you know, you can like return it and get the next car 2 years later. Then spot instances came about, which is renting just for a short period of time for much cheaper. And you can also rent cars for like a weekend. And then in the like auto industry, this thing called Car2Go came about, which I don't know, do we still have that here in Minneapolis? Not anymore. Well, anyways, there's cars like there's these little cars all over, and you can just for one, you just need to go to the grocery store, for instance. You can jump in, pay just for the minute, pay by the minute, go to the grocery store, get your stuff, and come back home, and you've just paid. So it's making it, like the industry is moving it towards making it easier and easier to not own your own car. And that's the same with serverless. It's just making it easier for you to not run your own servers. You pay for serverless stuff by the millisecond. Similarly, with these cars, you pay by the minute. I need a drink of water really quick. Sorry. Okay, so this is my first attempt at serverless. I didn't know what to do, so honestly, like I remember this. When I interviewed with Jamie, he asked me a really difficult question, and I was like genuinely stumped, and I just froze, and I was like, well, and he's like, how would you do this? And I was like, I'd Google it. And that's sort of how I go about solving problems. Is I first Google it, and then I also ask people who I think are smarter than me, or at least make more money than me. I say, how would you solve this problem? So I asked multiple architects, like, okay, I have this problem. How would you go about solving this? And multiple, at least two, said, oh yeah, easy. You just like orchestrate some Lambdas with step functions that go for that. And I was like, oh, okay. So who here knows what a Lambda is? Let's raise your hands. Figure this out. Okay, more of you guys. That's good. Just because not everyone does. A Lambda is a small unit. This is like the car I was showing, the Car2Go. It's like a function you can run in the cloud, and you pay by the millisecond. It can run for as long as 5 minutes, no longer than that. It's used for smaller processes then, obviously. And you can't, one limitation I ran into was you can't, you have to load into the Lambda whatever resources you need, like external libraries. So if you just need things like requests, the requests library, or I'm talking Python here. But if you need smaller libraries, that's totally fine. But I tried to do some things with bigger data science packages, and it just didn't fit the requirement. You have to have, it has to be under like 250 megabytes, the dependencies. So if you have bigger dependencies, like it's not suitable for Lambda. Lambda is really suitable for smaller scale things, smaller, like 1 unit of work. Okay. What happens when you have multiple functions and you want them to work together? Maybe you want one function to do something, return information, give it to the next Lambda. That Lambda does something. How do you orchestrate it? You have to have code outside of the Lambda that orchestrates and manages those Lambdas. What kicks off the Lambda and how where the information goes after it returns. So that's where step functions comes in. It came out after Lambda, I think just within the last year. Was it last fall? And it's a state machine. So you write code that says, hey, start at this Lambda. Okay, run this Lambda. So whatever code is inside the Lambda, that's written somewhere else. That's you deploy that Lambda, and then you write this state machine that says, hey, start at this blue Lambda. Whatever gets returned from the blue Lambda, give it to the red Lambda, run the red Lambda. Whatever gets returned from the red Lambda, give it to the yellow Lambda, and then the process is finished. It can do other cool things. It can have a choice state. So you could say, run the blue Lambda. Depending on what is returned from the blue Lambda, either run the red Lambda or the yellow Lambda. So this is interesting because we're used to writing functions. Like if you're comfortable, we're used to writing functions, and essentially you're just writing functions, but it's just at a different level of abstraction. Now you're writing these functions, and they're individually running in the cloud instead of all running packaged up in one EC2 instance. It can do parallel processing. I put that in quotes. So what it can do is it can say, run the blue function, then after the blue function's run both the yellow and the red function at the same time. Okay. However, what I needed it to do was different. It was a different type of multiprocessing. I was saying, run the blue function, get a list of device groups, and I don't know how big that list is going to be. I don't know. But for each item in that list, run the red function, which is to get the devices. And you can't hard code that in. When you write the state machine, you're literally defining the next step is the red, or the next step is the yellow. So you can't say the next step is, it's not there yet, but hopefully it'll get there. There is a forum online if you guys want to Google and like add to it and be like, please get me dynamic fan-out processing. That'd be really great because I want it and other people do want it, and so it might come along. So this was my first attempt. I think I pressed this at getting this data. It just fell short. Just want to keep watching this. Step functions just fell short for what I needed it for. But it is really cool, and it has some pros and cons to it. So it might work for your use case. So what can it do? It doesn't just orchestrate Lambdas. It can also orchestrate EC2 instances. So you could say, kick off this EC2 instance. This process is what they're called. There also is built-in backup. There's a built-in backup policy, which means if the Lambda fails, you can write in a rule set that says, okay, try it 3 more times and then wait a minute because maybe something's going on the other side that I don't know about. So yeah, the con for me that I discovered was that it doesn't support this one-to-many fan-out architecture. And that's about as far as I got with it before I pivoted to a different architecture. Okay, my second attempt. So then I heard about this cool thing called event triggers. Who knows what an event trigger is? Okay, cool, less. We're getting deeper into this, like, I don't know. So, do you guys know what, who knows what an S3 bucket is? Okay, more people, that's good. So an S3 bucket, it stands for Simple Storage Service, and it's just an object storage. You just stores objects in it, and so with event triggers, what happens is you have these keys, and I treat it basically like a file system, even though it's not a file system, it's like an object storage, but each object has a unique key to it, and you can write the keys like, I can write objects to this key, device group / blah, 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 blah. And so it's essentially treating it like a file system because I'm writing them all to. Okay, so what I can set up is an event trigger which says, when something is written to this key, device group / anything / star, trigger this Lambda to run. So this first Lambda goes and gets the device groups, and then it writes a unique file for every device group. And every one of those files triggers a Lambda to go get the devices. What? Fancy. So then, this is going to get boring because it's the same logic. This Lambda, this red Lambda, well, it reads the file first. It reads this file, and it says, okay, I have a device group. So then it goes and it asks Hermes, the API, give me the devices for this device group. And then it writes those to this key, and it'll write a unique file for every device, which will then mean another fan out. So then each one of these guys, and this is all happening at the same time. Like these 3 Lambdas are getting triggered at the same exact time. Your limitation with AWS is you can run 1,000 of the same Lambda concurrently. So I ran into that because we definitely had more than that. But in addition, I ran into I was hitting their API way too fast. Like it was creepy. It was just like, whoa, slow down. Like they weren't ready for it. And so it was a Sunday. I was like messing around on my own, and then I got a message that was like, hey, are you playing? Like I think Andy. Oh, he already left. Andy was like, are you playing around? Our service is down. Their service is down. And so yeah, they didn't actually have rate limiting in place to protect themselves. So they were down for an hour, and I had to quickly shut off the process from running. Okay, so using event triggers with S3. It's super fast. If you have things that aren't like calling an API or interacting with an external service, you can run a lot of things right away. Multiprocessing can be really, really fast. But you can't control the rate the Lambdas get spawned. I couldn't say like, hey, run, like it just as soon as that file gets written to S3, it triggers the Lambda right then. And then if it fails, it'll only try, so this is I'm not sure. It either tries 2 more times or it retries 3 times. It's either retries 3 times or it tries 3 times total. That one I'm not sure. We'd have to look at. But I should know that. I'm sorry. So what ends up happening is, in addition, if you had a system outage and you had some that were in the middle of processing, you'd just lose that data. Like it wouldn't be re-triggered. So it's not very resilient. Okay, so I pivoted again. This is my 3rd attempt, which is rate limiting. So I had to pivot because this was going too fast. I wouldn't be able to get my data. I wouldn't be able to slow it down with the event triggers. I spoke with our vendor, and they said, okay, well, originally we didn't have a limit. And I will say, at the beginning of all this, I did ask them, I did say, at what rate can I hit you guys? And they said, oh, as fast as you'd like. So, but then afterwards, when we had the conversation, they said, well, actually, we have a new rate limit, and it's 60 per minute, which is really low compared to it. So then we bumped it up to something more reasonable, and but I needed to change my architecture. Okay, so a queue is like what you would imagine it to be. SQS queues in Amazon. It's a line, although it's not strictly first in, first out. Like a line that you'd go into, you'd imagine that the first person would get processed. But because you can have multiple consumers coming, grabbing things from the queue, you can't promise that the things that will get grabbed off the queue will be first in, first out order. But it is. And I had another. Oh, okay. You can grab up to. A consumer can grab up to 10 items off the queue at a time, And when this happens, they become invisible to other consumers. So that way which is really cool, because otherwise, if I grabbed 10 items and then my friend Sally grabbed the same 10 items and we tried to process them at the same time, that's a waste of time. So there's a default invisibility period, but you can set it. You can say, like, if you know your Lambda is going to run for 5 minutes, you could say, keep this thing invisible for 5 minutes because I'm not going to delete it until it's processed, which is part of the way that these queues work. You have to delete the item after it's processed. Grabbing it from the queue doesn't delete it. Grabbing it from the queue just makes it invisible until you delete it, or until the invisibility timeout gets set. Okay, that's pretty much what I wanted to say about queues. CloudWatch Rules. These are pretty cool. It's like a cron job if you're familiar with that. Otherwise, it's basically just it's a scheduler. It says I want to run this job at this specific time. So that could be I want to run it every Tuesday at 9 a.m. or something. I want to run it every hour, every minute. Okay, so this is the new architecture. So I start with the blue Lambda. I get all the device groups, and I throw them all on the queue. And then these three are running on CloudWatch Rules. So they're actually all running on CloudWatch Rules. But this CloudWatch rule is set to something that's bigger, like every 2 hours, let's say, or however often I want this whole process to kick off. So these three are running every minute, actually. And so, and they're variable. I could set them to any CloudWatch rate, although the minute is the minimum rate that you can set for a CloudWatch rule, which is a little unfortunate, but. Okay, so this red Lambda goes and grabs 10 items off the device group queue, and it asks Hermes, please give me the devices for this, and throws those onto the devices queue. And then it deletes once it does that for a specific device group, it then deletes the device group off the device group queue. And then these act similarly, it does the same process. And finally, it goes into an S3 bucket. So one good thing that came about that came through I can't speak. One positive thing is that the event triggers that I learned didn't completely go to waste. Because at the end of this process, I still didn't have data that I really wanted to work with. It was kind of coming to me in this gross JSON format that I wasn't super comfortable grabbing and analyzing with. And so I used event triggers then to say, okay, put it to this key raw data, and then every file that I write to raw data, trigger a Lambda to then process and clean that data into a format that I'm more comfortable with, and then put it into this new key under the key CSV. So so it'll be like raw data / production / blah, 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 blah. And then until it goes to, so it's just sort of this file structure that I've created, but there's two. And then eventually I'll have something in place to delete the raw data because I don't really need to store 2 copies. I just want the format that I want it in. Okay. So here are some pros and cons of queues. They can store tasks that fail indefinitely, which is really, really nice because one advanced feature that you can do is if your queue or if your task fails multiple times, you can actually then say, you can set a rule that says, send this to this dead letter queue, send it to this other queue because it's not going to ever process, so just get it out of here. But I need to look at it. I don't want to delete it. I want to look at it and figure out what's wrong with it. So that's really cool. You can rate limit with this when you use queues because you can have as many consumers as you want. You can have many, but basically it's not an inherent feature of the queue. You put the items on the queue and then you decide how many producers you want to be writing to the queue and how many consumers you want to be grabbing from the queue. So yeah, it's not, you can't count on it being first in, first out. For most use cases, I think that's okay. It's just something worth noting. And you could have this the situation where you have a small task that you want to be processed, and you won't be able to estimate how long it would take because without looking at the queue, the size of how many items are in the queue. Because if you have a ton of items already in the queue and you put this small task on there and it should only take milliseconds to process, but it's backed up, the queue is backed up and it has a bunch of items on there, it's not going to get processed until a bunch of the other items get processed. So you won't necessarily be able to know or estimate how long this one specific task would take. The tasks aren't independent of each other. They become sort of backed up by each other. And what are the pros and cons of CloudWatch triggers? They allow for quite specific schedules. Like I said, you can say, Saturday at 9 or every third Saturday. I think. I don't know about that every third Saturday. Can you do that with? I don't know. Okay. But the minimum schedule is 1 minute. So I guess for me, I found like it works because I had to really slow my stuff down. It works to just run one every minute. But if I wanted to speed it up, I'd have to look into how to orchestrate that. Like maybe I would have to set, like a gross way is I could set more than one CloudWatch rule for the same Lambda. But I would have to figure out how to orchestrate that, I guess. Okay, so essentially through all this like process of architecting and re-architecting, I wanted to share sort of what I learned. Just in general, is that I now know to really expect limits. I did ask at what rate can I hit you, but I took for granted, I just allowed it to become an assumption. When they said, don't worry about it, I just said, okay, I'm not going to worry about it because I have enough other things to worry about. But now I know to not trust that, and I know that I'll be like, no, I need to know what limit I can really, and just like build it into your architecture. Just know that other people, other services are gonna have limits. And I just know to now build that in, as part of my architecture needs to account for rate limiting. And so yeah, that was my next slide, was that basically with serverless, expect that you will be able to surpass whatever limits other services have. And so write your architecture in a way, or this is my lessons learned. I'm going to write my architecture in a way that can deal with that, which is also part of it. This has two meanings. Like one is expect myself to fail and re-architect. Like I think I became really confident just from talking to architects about the step function solution. So confident that I pitched a talk proposal for a solution that I hadn't written yet, and then I had to re-architect my talk for that conference because I wasn't going to use step functions. So expect like personal failures, but also expect that you will have to handle failures and know that. And so I need to be able to write code in a way that can handle these failures, that where I don't lose items, I don't lose job, or that also I'd prefer to not duplicate work as well. Okay. That's it, and I'm willing to take questions.
I got it to turn on. Yay. Okay, that was really awesome, Dana. I especially like that you took us through a lot of those windy paths that didn't turn out to be the right answer, because I feel like think of all the people who now are not going to waste time like on something that will turn out for them. They'll have similar experiences to you. So I'm going to take the mic around and let people ask you questions, if that's okay, for a couple minutes. Because I think also, do you want to tell folks where you're going to give this talk next?
Oh yeah, so I'm practicing. I'm going to be speaking at QCon in San Francisco a month from now. So your questions will be really helpful for me, and any feedback afterwards is going to be really helpful for me to help clean it up and work out the kinks. So hearing what you didn't understand will be really helpful for me.
Okay, we're gonna take questions from the crowd.
That was great. So the question I have is, how often do you do this, and how long does it take to complete that data collection, and then how much does it cost now in the end state that you've arrived at?
Okay, so right now what we're at is I finally just got to a working solution, so that we might work this out and this might change. But right now I'm collecting data from 8 to 4 every day. So I run it once. The first one I run once every 24 hours, and then it grabs data from 8 to 4 just during busy times. And the cost, I can't give you a number yet because I haven't done the analysis on that part, but that's a really good question.
Hey, really enjoyed that talk. That was really fun. I was kind of curious. I mean, I spent a lot of time reading about stuff like Jepson and thinking about data loss and these sorts of scenarios. And I was kind of wondering, since you delete stuff off the first queue, as soon as you process it, what if something fails partway through? Do you lose that, or do you have any way to deal with that, or how are you handling errors?
Yeah. Let me think about that for a second. So it would get. That's a really good question. I have to think about that.
Ready for QCon?
Yes, that's really. I'm gonna think about that one.
You're giving her homework to do in the
Yeah.
next month.
Yeah.
She can anticipate all these questions.
Yeah, exactly.
Okay. Do we have a couple more questions? Oh, we have one near the front. Okay.
I also thought you did great. What was the what's the end goal with the data? Like once you pull it home, what do you do with it? How long do you store it for? That kind of stuff.
Yeah. So it's not totally clear how long we'll store it for, but we want to use it for load tests. We want to be able to analyze the data. So one example is if we make one change to our system and we want to test how that change affected our system performance, we could overlap graphs to show, okay, well, last load test, this was the performance, and this is what it is now, so we can pinpoint what things have changed. That's one example. Yeah.
So you did. I have a question of my own, and then we'll go back to the crowd. You talked a little bit at the beginning about the initial problem you were trying to solve, but it sounds like maybe as you iterated, the problem set that you were looking at changed a little. Can you talk a little bit about the problem that you thought you were trying to solve and the problem you actually solved, and like any discrepancy or anything you learned along the way?
I guess I definitely thought I underestimated the amount of time it would take me to do the data engineering piece, because I took the job thinking, oh, I really just want to get in and analyze things, but it wasn't at a place where I could really start analyzing things, and so I had to learn this whole new skill set of how to deploy things and AWS was completely new to me. So I wonder if I could do it over again. Like it's always easy to say in retrospect, But because I grossly underestimated how much time the data engineering would take me, I probably would have started with a smaller started analysis with one team maybe, and then tested that, because we have like more than 27 services. I know I had at least 27 meetings in one month, meeting with different service teams and learning their architecture, and I probably would have done it a little bit more iteratively, like with one team, and test out, is this analysis useful? Okay, and then iterated. But
And it sounds like you're taking a more iterative approach as you go too, like what you're describing here.
mm-hmm.
Just going to move to this side so that I can get the mic over to people. It's like bad strategy, great picture taking from that side, bad strategy to try to get the mic to more people. Okay. I see one more back here.
I'll also say it was a great talk. Thank you very much. All the examples were AWS. Did you look at any other cloud platforms like Azure or Google? Did you consider any of those? How did you decide on AWS?
Good question. I just went with AWS because SPS Commerce, where I work, is largely focused on AWS. So the resources I had at hand, like in terms of mentoring, helping, were familiar with AWS. So I didn't make an assessment. I just picked what was close to me.
Took down the Oracle, could you then have leverage to say, give me a export all endpoint? Did you ask that question?
They actually did offer, they said, we're going to look into our, but I don't think that's something that they could just give us right away. They would probably have to build that out, and I don't know, I guess I didn't want to rely on how long it might take them or when they would prioritize it. But yeah, it would be beneficial for them too if I'm making less calls.
So for those of you who are designing SaaS services, think about the customers like Dana out there. I feel like we probably have a couple more people who have questions, but I have one more,
Okay.
which is, as you're working with all these teams, what kind of questions are they asking you, or what kind of things are you wishing that they told you up front? Like, as you're trying to figure out what's going on with their data. And this is kind of, it's not specifically about this project, though it relates, but it's kind of the whole data science question. How do you figure out what to even ask them?
Yeah, it was more of a conversation where neither of us had the answer, but we came together in the meeting to try to work out a solution together. And I think I'm still at the point, I'm glad that I went through this process because I have more empathy for developers. Like originally going in and just having my data science background, but not really having experience building out large-scale systems that are working in production. I was mostly just working from my computer, and then I had a nice DevOps person to do the DevOps for me, or write out the instructions for me instead of me having to start it from scratch. So now I'm at the point where I really want to get a better understanding of how are we supposed to monitor these serverless applications? Like, what is the best way? I mean, we don't just have, we have other services too, but I don't know if I'm not really answering your question, but that's sort of where what the next question that I'm interested in delving into is trying to answer, how do we monitor serverless applications?
And I think that's a great question, and one that I think a lot of people who are starting to use serverless applications are asking themselves that. So when you figure it out, write a blog post, give a conference talk, let us know.
So serverless is hot right now, right? And so, but the question is, did you have a plan B? Like if serverless didn't work, you did try EC2 instance, but was there ever a temptation to go back to server full?
Yeah, there were many temptations. And that was my plan B. Like, it was working. So, yeah, it was working to just grab it it just was more expensive. And then I wish I could say exactly how much because it's significant. I don't remember who had asked that question. It is a significant cost difference. I think that would be really useful for this talk to show the exact cost difference for people to.
Can you not say because you're not allowed, or do you just not have that specific piece of data with you?
Yeah, I just don't have the data on me. Yeah.
Ooh. Do you want to repeat?
Oh, they don't tag Lambda. Yeah, that's just our company, right? Oh, it's AWS. Do you want to answer that?
I'm going to give you the mic.
Yeah. Yeah.
I didn't raise my hand. AWS doesn't tag the Lambdas on the billing report. You don't necessarily have the insight to know which function is being invoked how much. So you'd have to build out your own analytics.
This sounds like a very exciting project that somebody could work on and open source and become super famous. And somebody right now is looking at GitHub and they're like, but there is one that you can improve. This is how it works. All right, do we have we have more hands up. We're gonna keep taking questions as long as Dana has patience for this. So.
Okay, so when you look at testing a code change that you might have in some part of the data extraction, are you thinking
rerun some of the data into the queues, or do you just write the same thing to different buckets and ensure the data is the same?
Can you repeat the question? I'm sorry.
So if you're
You can
Yeah,
say
how-
the
how
same
do
thing.
you-
I just
how do you test this? Are you saving the queues and rerunning them, or would you think about saving the queues and rerun them, or would you reload the data using the new code and validate that the endpoints are the same or the end results are the same?
Okay. It's a really good question. And this could be its own talk. There are significant problems with the data that I'm collecting in terms of trying to do analysis on it. One is and it has to do with the service that we're using is built with certain assumptions in place. They're built to be a monitoring service in real time. So that means they don't care about old data because the only way you can zoom out and it gets more, essentially what happens is if we have a lot of ephemeral services and when they go down after a certain period of time, that data about that ephemeral service goes away. So when I ask for the data, it really does affect whether I get the data for the ephemeral services or not. And so I don't have testing in place, and I am definitely missing important data because if I'm asking for it every 24 hours, that means that some stuff that has gone down within the last 24 hours, it might have already been deleted from their system. So the only way I could account for that is if I ran this process more frequently, but it's just a limitation of where I'm getting the data. And I don't have any way to account for how much I'm missing, which is really bad in terms of data analysis. So it's a good question. It's sort of what do you do when what is available to you is just gross, you try to do your best, but I actually just thought of my answer to, I don't know your name, I'm sorry. Mike? Donnie, okay. Yeah. Okay, so Donnie's question was, so Donnie's question was, if you delete the stuff from the queues prior and then you get to a point, maybe could you repeat it? Because I have it in my head, I have an answer. I think so.
Yeah, so the question is if you're deleting stuff from the first queue before you finish the whole transaction, how do you make sure you're not losing things in the middle?
Okay, so I think this answers it. But what I'm doing is it's basically one task, and stuff is getting added to that task. Information is getting added to that task along the way. So at the beginning, the task just has a device group. And then afterwards, it has a device group and a device. And then it has a device group, device, and data group. And let's say at that point, it just kept failing. At that point, it would stay on that queue. It would be a task that just stayed on that queue and never got processed. And I could have some system that wrote it to a dead letter queue. But it would be still one task. Even though it's deleted from the other two, those are just previous states of the same task. So I still have, does that answer it? I don't know.
So the value carries forward.
Yeah,
So the value that is output by each task is carried forward to the next.
Yeah, exactly.
So you could reverse engineer it by saying, what's the value at this state? Here's all the ones from previous.
Yeah, I don't even have to reverse engineer it. It's a dictionary. It's essentially a JSON dictionary, and at first it only has one value. It has the device group. Then when it gets passed to the next queue, it has more information in it. And then it gets passed to the next queue and it has more information. But so those previous states don't matter anymore because they're just previous, because I have the end state, which includes all of the previous states. I think that's what, yeah.
One more question I have is more general question. So given that the cloud, so elastic and just wonderful, but every click that you make is billable. How much does that ever enter in the back of your mind, that thought, how do I balance the fact that I'm just going to run this data set or this test, you know, and how is it, how realistic is it? And if it is realistic and it's a big data set, did I just blow through $1,000, for example, or whatever the cost may be? Does that ever enter into your thinking here, or do you ever get feedback of, you know, what your day was worth that way, you know, what it cost?
Yeah, I think part of the running the EC2 instance that was at 700, just discussing with my manager, it was pretty clear, like, this is kind of, we're hitting a limit, like, where this isn't really worth what we're trying to do, so let's talk about a solution that's cheaper. And definitely we have issues with, like, we want to, as a company, we want to embrace, like, change and growth and innovation, and yet, like, our AWS bill is, like, high. So there's definitely a conversation there with each individual manager. And I think I feel confident to play with serverless because the Lambdas are very, very cheap. It's like, do you have a rate, Nate? But they're really, like, significantly. Wait.
I think the first million is free.
Yeah, they're very inexpensive. And it's billed for the amount of memory that you allocate to the Lambda, and then for the duration billed, I believe, on milliseconds. So if you have relatively quick operations, you can have millions of invokes and pay pennies.
Mm-hmm.
Slight correction to what I said before, they do have tagging, they added it this year.
Oh.
And you know, I mean, reInvent's going to come up and they're going to just tell us about all sorts of exciting new things. So, all right. I think we're probably about out of time for the group to all sit and listen to your questions. And so now I guess we can go to the traditional mobbing the stage to ask your individual questions. Thank you so much, Dana.